Hi, this is Mark Lance again here for our next lesson to prepare you for the GED test. The last time we worked on problems where you had to add and subtract fractions and mixed numbers. Today we're going to take the next step and talk about multiplying and dividing fractions. When we were little, most of us learned to add and subtract before we learned to multiply and divide. And the reason was because adding and subtracting was easier, and only as we got older in the second or third grade we started learning about multiplication and division. But with fractions it's the opposite. Multiplying and dividing with fractions is easier than adding and subtracting. Why? Because we don't need to find the common denominator. So let's start with a simple example. We have 3/4 times 1/2. Now just for fun, we're going to pretend that we could find the common denominator. So you probably remember that, let's say 3/4, the common denominator is going to be fourths. So 1/2 is the same as 2/4. So those two problems are the same. All right, so now we're going to multiply. And when we multiply fractions, we simply multiply the numerator times the numerator and the denominator times the denominator. In other words, we multiply across. Don't get mixed up with going like this, which is something else we'll talk about when we get to ratio. But anyway, so we multiply this. 3 times 2 is 6. 4 times 4 is 16. There's our answer, except we can reduce this. As another name for this fraction, we see that they're both even numbers, so at least 2 goes into both of them. 2 goes into that 3 times. 2 goes into that 8 times. So our answer is 3/8. But we didn't have to do all that. We could have just done, right from the beginning, we could have multiplied the numerator times the denominator. And 4 times 2 is 8. We got the same answer with one less step. So that's why I say multiplying fractions is easier than adding fractions. If you think about it, when we were doing addition and subtraction, and we talked about common denominators, we said that one of the ways to find a common denominator is to just multiply the two denominators. So when we do that here, we already have a common denominator. So we know that the common denominator is eighths, and now we're just going to find out how many eighths are we talking about. 3 times 1 is 3/8. Okay? So, lost my eraser. And if we're working with mixed numbers, it's the exact same thing. We convert the mixed number to an improper fraction and do the same thing. So if we did 1/3 times, or sometimes the problem will say 1/3 of 3 3/4. Okay, so here's this number, and we only want 1/3 of it. So we already know the answer is going to be less than this. So even though it's multiplying, and the word of means multiply, this is the same as 1/3 times 3 3/4. We only want part of 3 3/4, 1/3. All right, so here we have a mixed number, and so we want to change it into an improper fraction so we can do our multiplication. So that stays the same. And if you remember what I was calling the Sister Mary Victor way, this number is all about fourths. So here's a whole number, 1, 2, 3. Each of those numbers, 1, 2, and 3, has 4/4 in it. Okay? So 4/4 in the first one, 4/4 in the second one, and 4/4 in the third one. Or a quicker way to do it, the same thing, 3 times 4 is 12, plus 3 more is 15/4. Okay? 3 times 4 is 12, 13, 14, 15, 15/4. And now we can multiply. We're going to come back and look at another thing here in a minute. But let's just multiply. 15 times 1 is 15. 3 times 4 is 12. So there's our answer, but it's a so-called improper fraction. Once again, all fractions are division problems. This means 15 divided by 12. 12 goes into 15 once, and 3 left over, 3/12. That can be reduced to 1 and 1/4. 3 goes into 3 once, 3 goes into 12/4. Okay? And like we said the last time, at any point, the advantage of using these videos is that if something is confusing or you want to go over it, just stop, back up, and see where we're at. One more thing I want to show you. Let's go back to this step here. When we do multiply fractions, we multiply first. 15 times 1 is 15. And 3 times 4 is 12, and we got this. And then we had to divide because it was an improper fraction. Well, what if we did some of our division first? And you'll see what happens. So we're looking, it doesn't always work, but it works in this case. We look and we see that, look, 3 goes into 15. So why don't we do some of our division first? So 3 goes into 3 one time. 3 goes into 15 5 times. And now let's multiply. And now we're getting to work with smaller numbers, which you're probably going to like better. So 5 times 1 is 5. 4 times 1 is 4. 5 fourths. That's even an easier division problem. 4 goes into 5 once. And 1/4 left over. Okay? So the multiplication, in any case, is going to be numerator times numerator, denominator times denominator. If you start out with a mixed number, we convert it into an improper fraction and then follow that same rule. And if you can, you don't have to, but if you can, canceling lets you work with both smaller numbers to multiply and also makes your division problem easier. Okay? All right. Let's do some examples. We'll do our usual thing of doing a bunch of problems with what I call naked numbers, no words, until we get used to solving these. And then when we're done with that, we'll do some word problems. All right, so we have, let's do an easy one. 2/3 times 1/4. Oh, look, we can do some canceling here. We could just do 2 times 1. Let's do it. 2 times 1 is 2. 3 times 4 is 12. And there's our answer. But it can be reduced. You can see that 2 goes into both of those numbers. 2 goes into that once. 2 goes into that 6 times. So the answer is 1/6. But if before we started you saw that we could do a little canceling, that there is a little multiplication division thing going on here. 2 goes into 2 once. 2 goes into 4 twice. Now we have 1 times 1 is 1. 2 times 3 is 6. Same answer, and it's just a little bit easier. If we didn't cancel, we would have to reduce. And so this just, I like it, and most students like it too, that it lets you work with smaller numbers and work more quickly. Okay? All right, how about 1 5/6 times 1/2? Now just think about it for a second before we even start. This is almost 2, right? Here's 1 and then here's 5/6, so it's almost 2, and we want to multiply it by 1/2. We only want 1/2 of it, okay? So first let's change this to an improper fraction. Here's a 1, and since we're talking about sixths, there's 6 sixths in that 1, plus 5 more for a total of 11. Or, Sister Mary Victor way, 1 times 6 is 6, plus 5 is 11. 11/6 times 1/2. Here we didn't get a break. There's no canceling. 2 doesn't go into 11. So we're just going to multiply. 11 times 1 is 11. 2 times 6 is 12. Here it's not even an improper fraction. It's just a regular fraction. And we're done. 11/12. Okay? That brings us up to 2/3 times 21. So we don't want all of 21. We just want 2/3 of 21. So it's going to be less. See any canceling we can do here? Yeah, because 3 goes into 21. Okay, 3 goes into 3 once. 3 goes into 21, 7. And then we get our answer of 14. So all of 21 is 21. 1/3 of 21 would be 7. And 2/3 of 21 would be 14. So it all makes sense. Now we have 50 times 3/8. Now to make it more comfortable for you, remember 50, we could write this as a fraction, and the fraction would be 50 over 1. 50 divided by 1 isn't any different than 50, but now you might like it better because they're both fractions. Now we could multiply 3 times 50, which is 150, but then we're going to have to divide it by 8. It looks like we can do at least a little bit of canceling because 2 goes into both of these numbers. 2 goes into that 4 times. 2 goes into that 25 times. 3 times 25 is 75, which you probably know from by heart just from thinking about money, and divided by 4. So 4 goes into 75. That's basically the same as this. 75 divided by 4. 4 goes into 7 once. Remainder 3. Bring down the 5. 4 goes into 35. 8. 8 times 4 is 32. 5 minus 2 is 3. And that's going to be the remainder 3. 3 what? 3/4. 18 3/4, or 18.75. Okay? So each time we do a problem, there's another sort of level of difficulty, but the same steps, the same rules, the same principles are going to be true each and every time. How about 3.5 times 1/4? So I'm thinking to myself, this is pretty close to being 4. 4 times 1/4 just means to take 1/4 of 4, and I think you know what that is. So let's change this first to an improper fraction so that they look better. 3 times 2 is 6, plus 1 is 7. 7/2 times 1/4. No canceling we can do here, so we're just going to multiply. 7 times 1 is 7. 2 times 4 is 8. It's not even an improper fraction, so we're all done. Okay? We're going pretty fast, so let's do another one. How about 3/4 times 7/8? Well, 7/8 is almost 1, but not quite, and we only want 3/4 of that. Now, let's see here. Again, I don't see any canceling we can do, so we're just going to go with 3 times 7 is 21. 4 times 8 is 32. I don't see any number that goes into both the numerator and the denominator, so that's it. Okay? Let's see. Next we have, this looks like an interesting one. We have 2 1/2 times 3 2/5. So you can see what we're getting at here. This is 2 mixed numbers, but it doesn't change anything. So let's find out how many halves this is. 2 times 2 is 4, plus 1 is 5. 5/2 times 3 times 5 is 15, plus 2 is 17. 17/5. And here we do get some canceling. 5 goes into 5 once. 5 goes into 5 once. Now look how easy it is. Instead of having to do 17 times 5, we just do 17 times 1. Divided by 2, and that's not going to be too bad. That's going to be 8 1/2. 2 goes into that 8 times, 1 left over, 1/2. Okay? Let's see, how about another? Here's another whole number one and a fraction. And this one's going to be 15. May as well save time and just make it 15 over 1 right now, times 2 3/4. Okay? If you want to stop, think about it for a minute, what we're going to do. It's going to be 15 over 1 times, change this to an improper fraction. 2 times 4 is 8. 9, 10, 11. 11/4. No canceling this time. And I don't know what 15 times 11 is. I think it's going to be 165. Let's see here. Correct. 165 over 4. Improper fraction. All right. Let's just turn it into a mixed number. 4 goes into 16 4 times. 4 goes into 5 once, with a remainder of 1 1/4. 41 1/4. Okay? So we did a couple of different steps here. If any of that's confusing, again, my advice would be stop the video, go back, go over it, and see if that works for you. All right, our last one before we move into division is going to be 5/8 times 3 1/4. So 5/8, that doesn't change. 3 times 4 is 12, plus 1 is 13. 13/4. Sorry, no canceling. 5 times 13 is, I think, going to be, I better check. 5 times 3 is 15. Yeah, 65 over 32. 32 goes into 65 twice. 2 times 32 would be 64. And remainder 1, 1/32. Should I do that as a division problem? This means 65 divided by 32. Hope I'm right. 32 goes into 65 2 times. 2 times 2, 32 is 64. 5 minus 4 is 1. Remainder 1, 1/32. Glad I got that right. Okay, so that's multiplication of fractions and mixed numbers. Next thing we're going to look at is division. I just wanted to mention, as I did after the other lessons, a book that I wrote that you might be interested in, or if not you, your children or grandchildren even. It's called The Weber House. It's set in Maine. It features 2 13-year-old girls who set out to solve a mystery of a 200-year-old pirate's treasure. And it even has some math in it. Hope you might like it. Thanks.